Hello everyone, welcome to the online video. Today we will go through the hydrocarbons. So as you look at the agenda, we will have three parts. First we will go through the learning objectives, and secondly we'll go through the definition of hydrocarbons, and third we will go through three types of different hydrocarbons. So as you go to the learning objective, we have 5 parts. So first, we will introduce the organic chemistry includes the study of carbon. And second, the composition of hydrocarbons. The third, we will introduce alkanes. And the fourth, we will introduce alkenes. And the fifth, we will introduce alkynes. So let's briefly go through what is the definition of hydrocarbons. So this is a wonderful name. We can see the name that hydrocarbons is made of hydrogens and carbons. Please be noted that we are only talking about these two elements. Carbon is a very magic element in the periodic table. And carbon can bond in long chain-like structure and rings. Therefore, it forms like 3 million of compounds, which represent 90% of all known chemicals. In the meantime, carbon is the only one in periodic table that has property that can make it possible for living systems to develop. It can have very complicated structures, but now we are only talk about these two elements, hydrogens and carbons, and it forms the simplest organic compounds. One characteristic of hydrocarbon is that the electronegativity difference between hydrogen and carbon is very low. Therefore, it forms the bond is nearly non-polar. We will then introduce 3 types of different hydrocarbons. One point to notice is that a hydrocarbon is not necessarily a single bond. It can form double bonds as well as triple bonds between carbon and carbon. Hydrocarbons are categorized by the bonds presented. So we will go through a little more about alkanes. The alkanes are a family of hydrocarbons containing only one single bonds between the carbon atoms. You can also identify them through the name end in ane. Alkanes are also classified as saturated hydrocarbon, and it can undergo combustions and substitution reactions. If you look at the chart to the right, you can see when it increases in chain size, it is a similar increase in boiling point. How is this so? Because of the intermolecular dispersion forces. We know dispersion forces increase with the mass increase. And if we compare octanes with methanes, we can see the boiling points increase from minus 160 to over 125. This is a huge increasement of the dispersion force. The general formula of alkane is here, and if you take N equals 4, then you get the butane's molecular formula, C4H10. Next, we learn more about alkenes. Alkenes contains at least one double bond between carbons. You can see here, every alkenes have one double bond between carbons. You can also identify them through the name ending in ENE. It is classified as unsaturated hydrocarbon. Alkenes can also undergo combustions and addition reactions. If you go back to the alkanes, alkanes undergo combustions and substitution reactions. Meanwhile, alkenes undergoes combustion and addition reactions. We will come to this later. And the general formula of alkenes is like here. The last one is about alkynes. Alkynes contains at least one triple bond. If you see here to the left, you can identify them through their name and in YNE, and is classified as unsaturated hydrocarbons. The general formula is like that. Thanks for the listening, and we will go back to the classroom for some exercises and review. Thanks.